All right, good morning, good afternoon, guys. I hope y'all are doing okay so far. You should be watching this video on Monday. I will be at my new job, seeing, hopefully, it's going well for me. I will definitely be missing you guys. I am so used to seeing you guys and starting my day with you all on Monday. I'm very sad that I'm not going to be there with you this week, but I will make these videos for you and you can continue to take your notes. And hopefully, I'll see you all at graduation at the end of the year. So today we're going to be taking a look at objective assignment number 12, objective 2. This is quadratic functions and their graphs, and we will describe graphs of the quadratic functions in the form x plus h. So I have a little mistake here in your handouts. I probably printed this x squared plus h. We need to scratch this out. We need to scratch this out, and we need to put the squared up here. Okay. Everywhere you see that, I made a mistake, and let's make that a squared. We're going to look at the quadratic functions of the form f of x equals x plus h squared. The question we should be asking ourselves as we watch the video is, how does changing the function transform the graph? We will describe graphs of the form f of x equals parentheses x plus h parentheses squared. This little 2, that's how we say it. We say squared. I will sketch graphs, or you guys are going to sketch graphs of quadratic functions, and you're going to label the vertex, the axis of symmetry, and the axis of symmetry. You guys should be writing these down in your note sheet that Ms. Escobar has handed out to you all for today. Let's define and explore. Transformations, what is that? We kind of need to define the word transformation so we can know what we're talking about. So do you all remember the graph of the function f of x equals x squared? That's what we covered Monday during my last week. And I said x squared, you're going to have an x and a y table. You're going to pick values, and I told you always pick these 5, and then just substitute them in to x squared. So negative 2 squared, that's going to be 4. Negative 1 squared, that's going to be 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. These are the coordinate points that will allow us to graph this function. So we have negative 2, comma 4. We have a point at negative 1, comma 1. We have one at 0, 0. We have a point at 1, comma 1. And then the last one is 2, comma 4. And this becomes the graph of our function. It's a parabola that opens upward. Okay, so I'm going to make a note because we're going to use this later. It opens upward, which means it's pointing up. A transformation is when we take this graph, x squared, and we translate it upward. So these are the words you need to fill in the blank: upward or downward, or you shift left or right. So we saw the case before where we had f of x equals x squared plus k, right? Let me rewrite that. K is ugly. Let me fix it. Where depending on the value of k, you either moved up or down on the graph, right? So now we're going to be looking at these transformations that are going to shift this left or right, okay? Let me put the colors to match. This irritated me. F of x equals x squared plus k. K made it move up or down. And now what we're going to see here is this h is going to make it move left or right. Again, I made this mistake. Please correct it for me. I'm sorry that I had already printed these pages up after I made the video, and I don't want to go reprint 200 pages. Scratch out the 2 here and put it on the outside of the parentheses. Now, if h is positive, so if this number is a positive number, then the graph is the same as y equals x squared, shifted left h units. So it's kind of opposite, okay? If h is positive, the graph shifts left. Usually the negative numbers are to the left. That's why it's the opposite. And if h is negative, then it's the same as x squared shifted to the right h unit. So if it's a negative number, we shift to the right this many units. Let's take a look at some examples. It'll make more sense here. First, let's graph g of x equals x plus 2 squared. So remember, this is our h, and in this case, our h is a positive 2. So the graph of x squared will shift. Positive goes to the left. 2 places left. So remember, our origin for x squared is always 0, 0. From 0, 0, we're going to go over 2. 1, 2. That's our new origin. Actually, you know what? Let me do it this way. I know this is our x squared. But when it's x plus 2 squared, let me see if this works. Look, we're going to go from there. We're going to go over 2 places. 1, 2 to the left. Every point stays the same. Every point shifts over 2 places. Okay? Let me show you how this works with a table. Remember those 5 numbers that I told you to use? -2, -1, 0, 1, and 2. If I substitute those in to this equation, I'm going to get -2 plus 2 squared, which is 0. -1 plus 2 squared, which is 1. 0 plus 2 squared is 4. 1 plus 2 squared is 2 plus 1 is 3. Squared is 9. 3 squared. Why doesn't this erase? And 2 plus 2 is 4 squared, which is 16. So -2, 0 is our first point. -1, 1 is our second point. 0, 4. Okay, so look, see, all those points wind up matching up. And then 1 with 9 would be way up here, but it'll kind of go like that. Okay. So you can see we can do the table and we get the same graph. Or we can just shift everything over to the left. 2 places. Let's take a look at example number 2. Okay. Our h value is right here. It's -2. And because it's negative, when we know we have negative numbers, we shift to the right. Okay. Negative number, I don't know why is my eraser not working. Okay. A negative number means we go to the right. How many? 2 places. Okay, so now you should be able to kind of see the pattern. We're going to go 1, 2. The spot that was here is going to go 1, 2. Here. And normally we have a point at -2, 4. So it's going to go over 1, 2. Okay. And that's it. Okay. If you're not sure about the points, you can always do the table. Making the table always works every single time. That should be enough to graph. -2 minus 2 is 0. -1 minus 3 is -9. 0. -2, which is going to be 4. So see, -2, 9 is way up here. -1, 9 is -2, 0. -2 minus 2 is 0 squared. I'm sorry, I'm stupid. It's negative 4 squared, which is 16. Let's do 2. Our x of 2, then 2 minus 2, that's 0. Okay, so that matches up. So you can always do the table, and it will work. What I want you guys to do now is work on practice graphing these functions on your own. You're going to look at number 1 and number 2. The other thing I forgot to show you guys in the first part, what is the vertex? Okay, I forgot to define the vertex. The vertex is the lowest point or the highest point on the graph. So in this case, the vertex is like this point right here in the middle, and that is negative 2, 0. And this vertex is 2, 0. So I'm going to put vertex. And a shortcut here is that the vertex, I should have defined it here. I'll put it right here. So look, the vertex is always going to equal h, 0 for this equation. So whatever h is goes here. In this case, it's negative h. So you have to take the opposite. So if h is 2, the vertex is negative 2. When h is negative 2, the vertex is positive 2. Okay, so you have to take the opposite of whatever your number is in the equation. Okay. Ooh, if you got lucky, you figured it out. You need to answer those on your own. Graph these two, x plus 3 and x minus 2, and then identify the vertex on your note sheet. Okay. Remember, I'll just go and show you. Your vertex is h. So if the vertex equals negative h comma 0, it's always going to be 0. Our h is 3, but we have to take the opposite. So the opposite of 3 is negative 3. Okay, it's not always going to be negative. This negative sign means opposite. Okay. And in this case, our vertex equals negative 2, and the opposite of negative 2 is positive 2. And then it's 0. You guys do the graph part. Okay, and that's it for this part. I hope you guys have a good week.